Next thing we're going to talk about. Okay, this is called an electroscope. Now, there are some, and we're going to diagram the electroscope and talk about the different parts, and we'll go into detail with it. But this is something, what this is a charge detecting device. It's a scientific device used to detect charge. Now, there's some very, very important parts of this. First off, right here, this is a metal ball. Okay? The metal ball goes into a metal stem, and this is locked rigid. It's iron. This is stem, yes. So this stem, it can't move. But here, we have things that we call the leaves. Okay? You can call it the leaves or the arm. Okay? And this arm is free to move. All good? So, put up a quick diagram. If you guys want to sketch it down, if you can't keep track of. Yeah. And generally how I'll diagram this, one thing I do want to point out, all this outside is, the only purpose it's there is to hold this up. Right here, this is plastic. That's going to be important later on. We'll come back to it. But really, when we talk about an electroscope, the only important part, you have the ball, you have the stem, and you have the arm or leaves. The reason we have leaves is there are also different electroscopes that are like this, and there's actually little gold foil leaves at the bottom that will move around, but these are a little more hardy. So, but this is the type that we'll be using in this class. Now, right now, a little bit bigger. Right now, what is the charge on that electroscope? It's neutral, okay? Meaning, there are the same number of positives as there are negatives. So, also, if all the negatives right now were down at the bottom, where do those negatives really want to get to?
The top.
Why?
Because the top is positive.
The top would be positive, so they'd go, oh, run all the way up to the top. So then all the electrons run up to the top. Where would they really want to go then?
To the bottom.
To the bottom. So under normal circumstances, electrons, if nothing else is affecting them, they're going to want to spread as far away from each other. So, they all kind of, buddy up with a proton. They're like, hey, how are you doing? Okay? So it's like a one-in-one thing. They want to get so that they're just paired up where they want to be. So when I draw this, I'm going to be pretty diligent to draw those in all by each other. Okay? All good? So that's the first half of the first drawing that we're going to put in. But I'll give you guys time to copy it down because this is a really, really important part that I want to make sure that we have everybody's attention on. So, really, really, really far away, I charge this up. What's charge on the electroscope still?
Neutral.
What's charge on this? Negative. Now, this is where everybody needs to watch. Well, if you want to zoom it in. We're going to be talking right here, or as long as you can see it.
Alrighty. Well,
So, what goes on now, if you can't see, get somewhere where you can see.
There we go.
As I bring this in close, now I bring it away. Now, did I touch the electroscope?
No.
No, so were charges from here able to jump over?
Yes.
No.
Unless if you hear a spark, or if I touch it, charges can't move over it. So, bring it close, and the arm moves.
Magic.
Why? Good question.
Physics.
Dang. So this, the stick. What charge does the stick have?
Negative.
Negative. Were there electrons up at the top of the ball before?
Yes.
Yes. Where do those electrons really not want to be?
Near the electron.
Near this. So when I bring this close,
They all escape.
well, would they all escape?
No.
A lot of them. They say, hey, I don't like those electrons. I'm an electron. Electrons don't like, well, yeah, it's like cops, and everybody runs. And where they run, they want to get as far away as possible from these electrons. So they run down the electroscope. They ran down the electroscope. What did that leave behind up here? Protons. So where did the protons go?
They don't move.
Closer to the.
Oh, they don't want that pizza party.
What?
Protons can't move.
Oh,
So the protons aren't.
Or else go boom.
The protons aren't able to run away because we aren't dropping nuclear bombs in here. Okay, Shamil's like, what the heck are you talking about? Yes, ma'am. If I bring you to the other side, it's not a. If I bring it right to the top,
What if you touch it?
Ooh.
follow the order on the sheet. Okay. So the idea is, if I come anywhere close to this ball, the electrons that are on the ball want to get as far away as possible. Now, the farthest away that they're allowed to go right now is down to the bottom.